Hello, my dear students. Now we are having next question. That is question number 24. A straight wire of length L can slide on the two parallel plastic rails kept in horizontal plane with a separation D. The coefficient of friction between wire and rails is mu. If wire carries current I, what minimum magnetic field should exist in space in order to slide wire on the rails? Okay, so definitely this current carrying rod will experience a magnetic force. Okay, let us consider this is these are the rails. Okay, and on this rail we are placing one rod of length L. The length of a rod is given as L. Okay, and the direction of current we are considering in upward direction, like that. This is the direction of current, and current I is given. The direction of current I is given. Okay, and the magnetic field we are considering into the plane of paper. Okay, now uh the the direction of force, the magnetic force, we can find using the Fleming left hand rule. Okay, so what is the Fleming left hand rule? This is the force, direction of force, the magnetic field, and direction of current. So the direction of current is in upward direction and magnetic field is in into the plane of paper. So this is the direction of force. Okay, so this direction of force F is along the rails, parallel to the rails. So definitely the friction force will work in opposite direction. This is the friction force, and this is this friction force is equal to mu mg. Okay, this mu we have to consider as static friction force because we have to find the minimum magnetic field, and the magnetic force F is equal to I L B. Okay, and sine 90 should be there, but we are placing this wire, current carrying wire, in normal magnetic field. Okay, so this ILB should be equal to friction, that is the maximum friction force, that is the limiting friction force, is equal to mu into normal reaction, and in this case normal reaction is equal to mg. If you want to understand using the FBD, so what you can do, you can plot the cross section. This is the cross section of wire, these are the rails. Okay, these are the rails. Okay, now the magnetic force is acting, in left hand side direction, like that. This is the magnetic force F, and the friction force acting in right hand side direction in between this rails and the wire. Okay, so this is the friction force. Okay, and to find the minimum value of magnetic field, this friction force should be limiting friction force. So this friction force should be limiting friction force. Okay, should be limiting friction force. So this ILB should be equal to mu mg. Okay, so B is equal to mu mg divided by L into I. Okay, so this is the minimum value of magnetic field, so that this rod just start to slide. Okay, on this rails. Okay, if you are applying the magnetic field more than this value, then acceleration will be there. So it is the minimum value, it is minimum value. Okay, it is the minimum value. Thank you very much.